Hi, I'm Victor, and today I will talk about using design principles for evolving complex software systems, in particular devtools, such that the users can get a coherent, consistent, and a high-quality dev experience. A few words about me: I used to be on Angular core team at Google, and for the last 5 years, I've been leading a project called Nx. You can find me on Twitter. You can read my posts online. This talk will use Nx, which is a fast and extensible build system, as an example. It is the most widely used JS tool for monorepos right now, which almost 1 million devs use, right? The examples will be about Nx, but you don't need to know it, nor do you need to memorize the exact things I will show you, right? I would encourage you to focus more on the general idea rather than the specifics, okay? This is how I think we should build complex systems, right? First, we want to decide what we want to build. For instance, in our view, Nx's goal is to be a powerful build system that can be used by organizations of different types and sizes and can successfully run their projects for 5 or even 10 years, right? Secondly, once you figure out what you want to do, right, you come up with a set of principles, and I'll mention them later, that help you get there, right? And finally, you make your day-to-day decisions, design decisions, right, using those principles. Right? The second item here is the most interesting item, and this is what this talk is about. The what are principles, right? They are rules that aid your decision making. So this Ray Dalio's book called Principles kind of covers the same idea, right? Essentially, he talks about using this sort of mental shortcuts, which help him make decisions based on past experiences, right? He encounters problems several times, refines it into a principle. Here you go. Now he can make similar decisions in the future much more effectively, right? They are stronger than best practices, but not absolute. You can have a best practice of, say, writing tests, which most folks would know about, but can still skip, right? It's harder to ignore a principle. You should only really do it if it's in conflict with some other principle, right? They are more concrete than the design philosophy or set of values. You can have a value of, say, stability, but it's somewhat vague, right? Kind of hard to know what exactly it means. With principles, you know what it means, right? And you will see it in the examples in the talk, right? Before I begin, I would like to say that I'm not talking about getting the best developer experience or the best set of principles, right? It has nothing to do with that, right? We're talking about getting something coherent and consistent, right, rather than the best one. An example here, we have 3 editors that I really like: Vim, VS Code, and IntelliJ. I like all 3. I use all 3. They're all very different, but they're clearly built in a consistent fashion because folks who develop them, right, have particular design principles in mind. Right? All 3 are great, right? So don't think about whether what I will show you applies to your project well. It doesn't matter. Rather think about how such approach can drive your decisions, right, when you're developing your project. Okay, so let's look at a few examples of principles we use when we on the team develop Nx. Okay, the first one, don't over-optimize for initial costs. This is more controversial in the JavaScript space than in some others. Right? In the JavaScript space, there is a very, very strong emphasis on ease of use or ease of initial use, right? Which I also think is very important, but we try to intentionally remind ourselves about something else, right? The ease of use on day 1 is very important, but it's not the only ease of use that matters, right? The ease of use on day 100 also matters, right? So think about 6 months from now, right? 2 years from now, right? Most interesting projects last for many years, right? Be a professional tool, right? Consumer applications have to be as easy to use on day 1 as possible, because the user only interacts with them for that long, right? Most of the time. The initial ease of use for them is of primary importance, right? Professional tools are a bit different because folks use them heavily on a daily basis, right? Every day, basically, right? So it's more important for them to be good at delivering value 6 months from now than when it comes to consumer apps. All the best apps I know, right, required some learning. And once I learned them, I could see why the gains are there, right? Finally, you don't have to be a Vim where the initial costs are super high, right? But you don't have to be something like text edit either, which is easy to learn but doesn't do very much. Striking this balance is, I think, the most important thing in the NX design, right? So we know when something will matter 6 months from now for a project or a year from now. We know it. So how do we retain that value while making the initial cost as low as possible, right? A good example here is something like TypeScript, right? Requires learning, for sure, but anyone who used it on a large project would never go back to using plain JS, right? There is something about it that justifies this cost, right? The second principle is more concrete. Code configuration is data, which is all the config should be analyzable by tools and should be non-executable. The third one is never break customers. So semantic versioning, I think, is no use for large applications or large organizations. Like, it simply doesn't matter whether you switch to the next major or not. If the major comes with a giant break and change, and an organization with 1,000 devs contributing to the same repo cannot do it, well, they cannot do it. Right? This means that the design mistakes, any design mistake you make, should be easy to fix, right? Because you are going to, and we are going to make mistakes, right? So we need to construct a system such that such mistakes can be fixed without breaking customers, right? So the solution is not to think super hard up front, right? That's not going to work. But to build a system where if we thought about something, put it in place, made a mistake, we can fix it without breaking folks. Next one is every work is different and every team is different, so everything in the result should be pluggable. So the tools should reflect the difference. Like, at some point, they will be different. Even if they start at the same place, 5 years from now, the needs of the team will be different. Right? If you have a closed tool, like a non-pluggable tool, to account for this difference, folks are going to build layers of scripts on top of it, right? Which means that some utility that the tool provides is going to be lost. There's nothing fundamentally wrong with this, right? It's just you break the benefits of a good integration. And good integration is very valuable, right? So we want to be more like VS Code, right? In this case, where it can do cool things on day one, and then as your project grows, you introduce new technologies and stuff, you can extend it via plugins and still meet your needs, right? The second thing that this principle kind of demands from us is that we treat all plugins, NX plugins, NX is a pluggable thing, right, in the same way. If we say have an editor integration, it has to work with all the plugins folks write in the same fashion, right? Okay, so those are some principles we have. Don't over-optimize for initial cost. Configuration is data. Never break customers. And everyone is different. Everything is pluggable, right? All right, so any build system, with any build system, there are two aspects that every developer has to interact with, right, on a daily basis. Configuration files and the command line API. So let's talk about configuration. That's perhaps the most interesting bit about designing the build system, at least at the beginning. Okay, so I'll show you how the next configuration looks like. And again, you don't need to worry about it or know it really. It's simply just so you have some idea what I'm talking about, right? If we run this command, create next workspace preset React, the command is going to create a new next workspace with a React application in it, okay? Again, don't worry about the rest of the files, but I want to draw attention to two files, annex.json and project.json. This is how annex is configured. Annex.json is configures the annex CLI itself, right? And project.json configures what given projects can do, right? How you can build it, test it, etc. Right? With this in place, when you run annex build my app is the name of the project, the annex CLI is going to read the contents of annex.json to understand project-independent configuration, and then we'll read the build section of project.json to see, what function should be invoked because you're trying to build it. In this case, it's going to be Webpack, and what options should be passed into that function, all right? And to make it clear for the folks who aren't familiar with Annex that the project.json is optional, you can remove it and use NPM scripts instead. But what I will show you next, hopefully will convince you that there is value in having it instead of NPM scripts, all right? The configuration on the left is the only file that's strictly required, right, in any given Annex workspace. Okay, so the first question we want to talk about, and perhaps the biggest one, is, should we use JSON or JavaScript for our configuration? Should it be executable or not, right? In this case, it's JSON JavaScript, but can also be Ruby or YAML, Groovy or XML. Different technologies, but it's the same set of trade-offs, right? So executable configuration, or in the web space, configuration in JS, has very many upsides, right? Firstly, it's a lot more expressive, right? You have a general purpose programming language at your disposal, so you can compose things, can compose functions, data structures. Composition is basically baked in, right? You can extend things easily, which is a form of composition, really. But some folks like to think of it differently. But again, it's baked in. It's right there, right? You can add support for, say, environments. Trivially, the configuration is more concise because you can abstract things away. You can try it up, right? Also, it's more familiar. Folks already know JavaScript, right? It's an internal domain-specific language, an internal DSL, right? Which, again, tends to be more familiar than external DSLs. Finally, it requires a lot less design. Okay, internal DSLs in general require less design because you have a general purpose programming language stuff to fall back on if something is missing, right? If you want to set defaults, well, write a function that sets defaults, right? That's that easy, right? There's a lot of power basically in this approach. There are a lot of upsides, right? And a lot of folks, the majority of tools in the JS space at least, use it for good reasons, right? But pretty much every principle we have go against it. First, right, never break customers. It is hard / impossible, right, to update JavaScript configuration automatically. So if you've made a design mistake, it's very costly to fix, right? Updating configuration requires you to parse configuration, interpret in some fashion reliably, and then write it back. We do it all the time, by the way, and I will show you how it works in a second, right? But it isn't possible to do at least well, or really in the general case at all, right? When using JavaScript, right? I wouldn't, if you want to try it out, take a giant Webpack configuration and write a script that reads it, updates it, and writes it back. It's very problematic. The second property is, the second principle it violates is everything is pluggable. All NX integrations should treat all plugins in the same fashion. For example, the VS Code plugin should provide auto completion for all of them, right? That's how we treat pluggability, is that everyone is at the same, provide the same experience, right? It is much harder to build a custom language service for JS than for JSON, right? In our case, if someone writes a plugin, their experience is immediately on par with any plugin we wrote as a core team, right? All the utilities work, automatic migrations work, editor integrations work, right? So everything works for them right away. Right? The third principle is don't over-optimize for initial costs. I think it's questionable, but I actually believe the JS configuration is easy to understand on day one. It's shorter, it's more familiar, it's internal DSL, right? But if you look at 2-3 years from now, right, 2,000 line JS configuration is borderline unmaintainable, right? And I would, you could try open any large React project with a giant Webpack configuration, you'll see what I mean. And not to pick on Webpack, it's a fantastic tool. It's just so widely used. It's, it's a good source of examples, right? So again, it violates an important principle for us. And it's such a clear cut, right, for us that we actually came up with a special principle to make such conversations easier, which is configuration is data, right? The special principle that just, closes all conversations in this area. JavaScript configuration is not data, right? So how do we deal with tools that rely on JavaScript configuration, say Webpack, right? Well, the way we do it, and a lot of folks in the Next community do it, right? Plugins that wrap those tools, right? But plugin is basically a function with a piece of metadata, so it's not super hard to write, right? But this wrapper, right, this function takes JSON configuration, right, and then passes it down to the tool that requires JavaScript configuration, right? So in this case, folks who use those plugins can move from one version of this tool to another one in a non-breaking fashion, right? You can move from Webpack 4 to 5, for example, which is a major upgrade, right, with minimum effort. And in this case, the JSON configuration can actually be shorter and often is a lot shorter than the JS configuration folks would have written themselves in the org, right? But it gets shorter not because JSON is more expressive necessarily. No, it's not the case. It's because we make some assumptions and we shorten it, right? If we used JavaScript instead, it would have been even shorter. Okay, second example is explicit configuration or conventional configuration. So if you're unfamiliar with the idea of conventional configuration, it's basically the style of configuration where certain properties, some defaults basically, are assumed and not explicitly stated. Right? Let me give you an example. So of how we deal with it and what we ended up doing. We have this property in the configuration in project.json called outputs. And this property lists a set of projects or files that can be created by the Webpack executor. When Webpack runs, it's going to put files into those folders, basically. Right? So next is going to look at those folders, archive them, and store them separately, such that next time you run the same exact computation, what it means exactly same exact computation is a separate point. Anyway, it knows you're doing the exact same thing. Instead of running the computation, it's going to unpack the files and put them in the right places, right? That's what that property is, right? As you can see right now in project.json, this property is present. We actually started with a pure conventional configuration system where this property wasn't there. We just assumed the output based on where your application is located, right? If your app is placed in apps my app, which is where this app is placed now, or the outputs will be in this apps my app, or seems straightforward, right? It's not necessarily bad. Again, it's elegant, it's shorter, it's less overwhelming, which is good, and it separates commonly customizable things from not commonly customizable things, which I think is the biggest benefit, right? It conveys something. Unfortunately, it's not aligned with our principles, right? It's harder to change a convention without breaking folks. The convention is by definition implicit, right? So updating to the newest version of Annex would update the convention, right? So a convention is a design decision, and because we try not to break customers, the most important thing for us, we need to optimize for making this decision fixable, right? When it's our own decision. Right? The convention is not the easiest way to do it. Don't over-optimize for initial costs. Again, if you have a new project, then starting with a blank file is usually simpler, so it's good. A year, or 2 years from now, 5 years from now, your repo is going to be, it's a monorepo tool. You'll have a bunch of projects in it, right, of different technologies doing very different things, right into very different folders, right? And because we are built systems that invokes existing tools, right, we don't re-implement the whole world, we're an orchestrator, right? It means that those existing tools won't necessarily align with our convention. Right? If you have a Next.js app, for example, and in the Next workspace, the Next.js app will insist on creating .next folder next to the sources where the project is located. Right? You just cannot change it. It will always be there. So if you have a Next.js app, the convention won't work. You have to deal with it. In this case, it's less of a clear cut than the first principle in that sometimes conventions are good, I think, right? When there is a low chance of breaking customers and there is very unlikely, the convention is very unlikely to cause a confusion, you can choose to use it. So we don't have a principle that says, don't use convention over configuration. No, sometimes it might be okay. Rather, we have a set of lower level principles, which we can use to examine given cases of conventional configuration, right? All right, next example is microsyntax. So in Annex, in a declarative fashion, you can specify dependencies between tasks, right? You can say, for example, before this app is built, everything it depends on should be either built or retrieved from cache if this exact computation has already occurred, right? You can also say before you build this project, run a different target on the same project. And you specify it like this. You list an array of rules, like sort of invariants, right? And next we'll read this array and we'll interpret them, right? To construct something like what you see on your right. So we could have introduced some custom microsyntax to shorten it, right? To make it more expressive, is what's shown on the right, right? And honestly, sometimes I think we should, right? It's so much shorter that once in a while I think, okay, maybe it's better. But let me tell you why we haven't done it thus far. First, let's imagine that this capability of defining those invariants can be extended. And of course, any capability can be extended, right? In this case, I could imagine that instead of listing just dependencies for self, I can also say that I can point to all projects in a workspace, or I can name a given project in a workspace when I define those rules. Or I can pass params in the task tree, right? They don't have to use the same params, right? Or different configuration, things like that, right? I can do different things to define those invariants. Well, it's sort of same old, right? As a result, microsyntax is a lot harder to extend. So design mistakes are costly. You're basically stuck with the design you had, right? It's very hard not to break folks when you make a wrong decision, right? Especially when it comes to things like passing params and the example I gave, right? I'm not even sure it's possible to embed them well into the microsyntax. Whereas maps are easy to extend in a non-breaking fashion. That's what maps are good for, right? Watch any talk about closure by Rich Hickey, and you will see what I mean. He talks about it at length, right? The next point is less obvious. Configuration is data. When you introduce custom syntax, you sort of introduce custom data types. And custom data types, although technically data, is not the same kind of data that we talk about, right? Or we talk about data that is easy to manipulate with. So when data is only built out of primitive values, that is the case. When you have custom data types, it's a lot harder to actually transform the data and do interesting things with it. Again, Rich Hickey and Closure, he makes this point a lot more eloquently. Right? Finally, everything is pluggable. So technically, you could write a plugin with some custom syntax, but the bar becomes a lot higher. Our goal is to lower the bar for providing pluggability. Right? When we say that everything is pluggable, we're saying that everything, like it's easy to write plugins. Right? Once we introduce microsyntax, can plugins add their own microsyntax? Who should interpret it, right? What part of the system? How would editor integration work with that thing, right? Trouble, basically. Without it, no trouble. And once again, we don't have a rule about no custom syntax at all. So it's not the same as configuration is data principle, which is very hard. In this case, we have lower level principles we use to evaluate whether a given example of custom syntax is okay. So adhering to our principles meant that our configuration isn't as expressive or concise as it could have been. It's true, right? If we wrote everything in JavaScript and heavily relied on conventional configuration, it would have been shorter, right? No doubt, right? It also would have been easier to implement. Internal DSLs in general are easier to implement, right? So we are sacrificing something, right, like expressiveness, but we get something in return, right? And one of the things we get in return is effortless migration. So in NX, this is a NX workspace. You can run a command, NX migrate, and point to a given version. And that command, what's going to do is going to fetch information about the plugin to use in your workspace. React, Webpack, Cypress, Jest, Spring, .NET, right? We'll fetch that information. It will do two things, right? It's going to update the versions of every plugin and other dependencies that the plugin needs in, say, package.json. And then it's going to create a list of recipes in the migrations.json file. And those recipes are going to update your workspace such that it can work with the new versions package.json now contains, right? I know this happens automatically behind the scene, right? So you don't need to do anything, right? Just magically works. With this in place, certain things become true, right? Firstly, the NX configuration itself never breaks when you go to the latest because we write it in a migratable way. Right? So if you use NX to build, say, your Next.js app with Cypress and Storybook, NX shouldn't be an extra piece of headache. It should only remove headaches, like make things faster. Right? If you use plugins for Jest or Webpack, the plugin that wrap those tools into a bit of JSON, right? Those updates again will work most of the time. Right? We try our best to provide the recipes that move your code to the new version of those tools and to update the config. Basically, the config in our case acts JSON config acts as an anti-corruption layer. It prevents you from breaking, right, when you move to the newest version of Cypress and Storybook, etc. Right? So it almost always works. Doesn't work all the time because we don't control those tools, so they can make changes that are fundamentally hard to move to in a non-breaking fashion. Right? And finally, such migrations can update executable source files and often do. Small changes are reliable, like import swaps and stuff like that, some renames. Larger changes are very hard to do, right? So it kind of works sometimes, like often works, but not always. As a result, though, because this process works, because of all the principles that we have that drive our design in a particular direction, like staying up to date with the ecosystem is a lot, the cost of it is a lot lower when you use an X. I'll give you one example, right? So there was this tool called TSLint, which was used to lint JSTS files, right? It was deprecated, basically died, right? So folks had to move to ESLint, which is a different linting tool, different rules, like looks different, etc. Right? So what we did, we had a set of migrations for moving from TSLint to ESLint. We have correspondence of rules to write your configuration correctly, such that it links the same thing, etc. Right? And with that set of migrations, folks were able to move from one to another one automatically because migrations did like 95% of the work. So large orgs with giant workspaces could do it in a couple of days, right? Otherwise, they would be forever stuck with TSLint. It's just a thing with a dead piece of code, right? We see it as a good trade-off. Our config isn't as expressive as it could be, and there is some extra complexity because we need to, actually analyze the external DSL, right? But we drastically decrease the long-term cost for projects, right? Folks can stand up to date with ease, right? I'll give you one more example where the idea of principles works, right? And has nothing to do with actually APIs or configuration. It's just the dev process itself can be informed by principles, right? So the way an X is released is that we release two majors, one in April, one in October, so twice a year. And then there is a bunch of minor releases in between, right? So we do use terminology of major minor releases to do planning, to communicate what versions are supported, what can be updated, etc. Right? So we on the team aren't against assigning numbers to things. Numbers are fine, right? What we are against when it comes to firmware is the idea that breaking changes are okay in major releases, right? Because it conflicts with our principle, right? Breaking changes are never okay. A large enough workspace, right, with 1,000 devs contributing to it, that workspace and those devs don't care what number goes up when they update. The first number or the second number, it doesn't matter. You cannot have substantial breaking changes, right? And it's just a fundamental principle of ours, so we don't use firmware in the same fashion. We do our best to minimize breaking changes in the tools we support, irregardless of the version we update to, major or minor. It just doesn't matter, right? It should be as non-breaking as it can be. Right, so we use versions just for planning. Like you do when you use other tools. When you consume VS Code or IntelliJ, you don't even know what version of VS Code you might be using. You just use the newest version, right? And presumably it works. VS Code doesn't just fall apart every 6 months because a new major version is released or something like that, right? And that's not okay for most tools, and it shouldn't be okay for DevTools as well, right? All right. To summarize, you need to look at 3 things when you, sort of 3 things in terms of importance. First, decide what you want to build, right? And next, fast and extensible build systems. That's what we decided we want to do. Come up with a set of principles that help you build what you want to build, right? And then use them when making everyday decisions, right? Check out Nrwl. It's really cool, especially if you use JS. It's perhaps the most interesting build system out there. I'm biased, but please take a look. And you can follow me on Twitter. Thank you.